Okay, the third topic is to find the intersection of two lines. So before this is we find the equation of line, and then from there we can find the angle of two lines, and now we want to find the intersection of two lines. In 2D coordinates where it involves x and y axis, the two lines can be either parallel or it can be intersect with each other. But for 3D coordinates, where for 3D coordinates involve three space where x, y, and z, so the two lines can be in one of these three cases. The first one, it can be intersect like this graph, or it can be parallel like B, or it can be skewed, where skew means that the lines are neither parallel nor intersect. So let these two lines, L1 and L2, are given by this symmetric equation, and L2 is in this symmetric equation, where this line 1 and line 2 are intersect at point P. So it can be like this. Okay, so for the parametric equation of the lines of this line can be written as x equals to x1 plus 8t, y equals to y1 plus bt, z is equals to z1 plus ct, and L2 is represented as x equals to x2 because point is x2, y2 and z2, and the vector is d, e and f. But you notice here we don't use the same parameter of t because it is a different line. So we have to use a different parameter that is not t. So we represent it as s. So here y2 plus es and z equals to z2 plus fs. So we have two parametric equations for line 1, and the second one is the parametric equations for L2. So remember that we have to use the different parameter of t and s for different line. Okay, so since the line is intersect at point P, so there exists unique values of t and s, which I mentioned earlier. So we can rewrite this as x1 plus at equals to x2 plus ts, where this is taken when for x, and this is taken for y, and this is taken at z. Because we know that from the parametric equations, for line 1 it is equals to x equals to x1 plus at, and for line 2 x is equals to x2 plus ds. So we just equal these two equations and it can represent it as here. So same goes with y and z. So if the lines intersect each other, so if we solve this and we get the unique value of t and s, it means that the lines are intersect each other. But if you don't get values for t and s, okay, which does not satisfy this linear equation system, then we can say that L1 and L2 are skewed. This is the diagram that summarizes how to find whether the line is parallel, intersect, or skewed. First thing first, you need to check is whether the line is parallel or not. So either L1 and L2 is parallel or not. In order to check this, we know that our L1 is parallel to V1 and our L2 is parallel to V2. So we have to check our V1 is parallel to V2 or not by taking this formula. V1 is equals to T V2 or either V2 is equals to T V1. So if this equation is satisfied, meaning that line L1 is parallel to L2. However, if it's not satisfied this equation, we need to determine whether the lines intersect or not. So to determine if the lines intersect or not, we have to write down in terms of x1 equals to we have to write down in terms of x1 plus at equals to x2 plus ds, y1 plus bt equals to y2 plus es, and z1 plus ct equals to z2 plus fs. So if we get to solve this linear equation, we get a unit value of t and s, then it means that the lines are intersect. So from the value of t and s, we can find the point of intersection. However, if we don't get any value of t and s, it means that the lines are skewed. So there are two steps to find whether the vector is parallel, intersect, or skewed. So in order for you to understand more about this, how to find whether the lines are intersect, parallel, or skewed, let us try this example. Let us try this example A. Given the symmetry equation of L1 and L2 is given as this. So we need to know the value of vector that is parallel to L1 and vector that is parallel to L2. However, before we identify all the value of the vector, what we need to make sure that is we have to make sure our value of x, y, and z must be multiplied with constant plus 1. So here, only this part is multiplied with negative 1. So what we need to do is we have to make sure that all the values in the numerator and the denominator must be divided with negative 1. So here our L1 will be equals to the same equation except for this, or we can bring out negative outside of this, so we have negative y minus 6 over 3, or this can be bring to the lower part. So here now no longer at the upper part, so this will be y minus 6 over negative 3, where this is equals to z plus 2 over 5. So for the L2, there is no problem. So since there are no problem with the second line, so we can now find the vector that is parallel to L1 and L2. So for L1, the vector that is parallel to L1 can be represented as V1. So we have here as 2, negative 3, and 5. And our L2, where the vector that is parallel to L2, we represent it as V2, is equals to 4, negative 6, and 10. So in order to determine the parallel, we have to check first whether these two lines is parallel or not. So to find the parallel of these two lines, we have to check whether our V1 is equals to lambda V2. So V1 given here is 2 minus 3 and 5 equals to lambda V2, which is 4 minus 6 and 10. So we need to know the value of lambda. So what we can do is we separate this. So we have 2 equals to 4 lambda. So for the first equation, we have our lambda is equals to half. And then we try to solve the second equation, where the second equation is negative 3 equals to negative 6 lambda. So our lambda will be half 2. And the third equation is 5 equals to lambda 10. Or, sorry, it should be 10 lambda. So lambda is equals to half. So meaning that for all equation, our lambda is equals to half. So it means that our V1 is equals to half of V2. Means that this line, these two lines are parallel. So it means that this L1 is parallel to L2. So since it is parallel, it means that the lines are not intersect and also not skewed. So we don't have to go to the next step to find the intersection and the skewedness of the lines, because it already stated here that the lines are parallel. So we can stop our calculation here. Okay, now let us try the next example. Given the L1 and L2 is in terms of parametric equation, where the parametric equation is in terms of x equals to x naught plus at, y is equals to y naught plus bt, and z is equals to z naught plus ct. So for our case, all of this is in terms of x, y, and z, and x, y, and z. So we can straight away identify the vector of the line. So here is A is equals to 2, our B is equals to negative 1, and C is equals to 1. And for L2, our D will be equals to 3, and then our E will be equals to negative 1, and our F is equals to 1. Okay, now first we identify our V1 is equals to 2, negative 1, 1, and our V2 is equals to 3, negative 1, and 1. Okay, first you need to check is the parallel of the line. So our V1 must be equals to our lambda V2. So here we have 2 is equals to lambda 3 lambda. Oh, sorry. No, I write down all this. So our V1 is equals to 2, negative 1, 1 equals to lambda V2, which is 3, negative 1, 1. So we separately, where the first one is equals to 2 is equals to 3 lambda, and our lambda is equals to 2/3. And for the second equation, it is negative 1 equals to negative lambda, and lambda equals to 1. So means that our lambda is not the same as the first equation. It means that we don't have the same value of lambda. So it means that this lambda, this line are not parallel. So since they are not parallel, what we need to do is we have to check the intersect of the lines, whether it is intersect or not. So in order to find that, we have to first write down the equation for x, y, and z. So we know that this one is 3 plus 2t. For x, it is equals to 3 plus 2t for the first line, where this is equals to negative 2 plus 3s. Okay, then our y is equals to 1 minus t, and the second line for y is 3 minus s, and the last z is 4 plus t, which is equals to 2 plus s. So here we have three equations. So we need to solve this equation simultaneously. First, we solve from 2, where we reorganize this. We get t is equals to 1 minus 3, which is minus 2, plus s. Okay, then we get this as equation 4. So we substitute our equation 4 into 3. We have 4 plus t, where t is equals to negative 2 plus s, equals to 2 plus s. So we simplify this, we solve this, we get 2 plus s equals to 2 plus s. Okay, now we try to solve the first equation. So we substitute our equation 4 into equation 1. So this means that we don't, for the previous equation here, we don't get any value here since it will be 0. Okay, now we substitute our 4 into 1. So we have 3 plus 2t, where t is negative 2 plus s, equals to negative 2 plus 3s. So 3 minus 4 plus 2s equals to minus 2 plus 3s. So we simplify this, we get s is equals to 3 minus 4 is negative 1, plus 2 is 1. So s is equals to 1. So we have a value of s equals to 1. So we substitute s equals to 1 into equation 4. So we have t is equals to negative 2 plus 1, which is equals to negative 1. So we have t is equals to negative 1. Now what we need to do is we have to check whether our s and t value satisfy these three equations or not. So we have to substitute t equals to negative 1 for the first equation. So this will be 3 plus 2 times with negative 1. So we have 3 plus 3 minus 2, which is 1. And then for the right hand side, minus 2 plus 3 times 1. So we have equals to 1. So meaning that s and t satisfy the first equation. Then we proceed with the next equation, 1 minus 1, this will be 2, 3 minus s, which is 2. So we satisfy the second equation. And then 4 plus t, this is 4 plus minus 1 is equals to 3. So 2 plus 1 will be 3. So meaning that our value of s and t satisfy all these three equations. So now we can say that the value of s and t is equals to this. So it means that the lines are intersect, where the value of the point of intersection, since the lines are intersect, so we can find the point of intersection here, where the value here for the first equation is for x, and the second one is for y, and the third one is z. So we can just straight away take this value of x, y, and z, where this can be represented as the point of intersection P, which is 1, 2, 3. So we can conclude that, so I will write here, the lines are intersect at point 1, 2, 3. Please pause this video and try to determine whether the following lines are parallel, intersect, or skewed.